position is 0, the initial position was 2, so we have -2, and that's meters. But what does that mean? That means that if you compare where it started, where it ended to where it started, it actually moved left. It actually moved left. Let's see how that manifests over here. Remember, we can always shade the area. So this area here we can shade. But how do you shade that area there? Where do you shade that one? You know? So the rule is you always shade between your line and the horizontal axis. You always shade between your line and the horizontal axis. So let's try to calculate these areas then. Let's look at this top area here. What's the area of this box right here? It's 2 times 1, so 2 times 1, that equals 2. Is that all right? But what is the area of this box down here? What do you think the area of this box down here is? It's not super obvious. What do you think the area of this box down here is? -4? Where did he get -4 from? I mean, if you look, it's 2 wide, and how tall is it? -2, right? Now, this isn't an actual area. It's like a conceptual area. Okay? It's like a conceptual area. And then if you add these two together, what's -4 plus 2? It's -2, which should match there. All right, so here's the question. I want you to check with your neighbor, and I want you to answer these 2 questions. Okay? So, here's what you're going to do. You're going to answer these 2 questions. What's the distance traveled and what's the change in position for these 3 times? Okay? From 0 to 2 seconds, from 2 to 4 seconds, and from 0 to 4 seconds. All right? So, with your neighbors, you're going to answer these questions. From 0 to 2 seconds, what's the distance traveled and what's the change in position? From 2 to 4 seconds, what's the distance traveled and change in position? And the whole thing from 0 to 4, what's the distance traveled and what's the change in position? Are you ready? All right, you're going to check your neighbor. I want you to write these down on your page so you have a good answer. Ready? 3, 2, 1, go. Answer those 2 questions for those 3 time frames. Come on. Do it now.
Oh, what?
So, from 0 to 2 sections, what was the distance traveled? Well, I mean, you can get it from either one of these, it's fine, but he started at 2 and he went to 4, right? So how far did he travel?
2 meters.
2 meters, that's right. What's the change in position from 0 to 2 seconds? Well, his final position is 4, his initial position was 2. What was the change in position?
Oh,
2 meters, right? Now, from 2 to 4 seconds, things are going to be different. Because from 2 to 4 seconds, his distance traveled is 4, because distance doesn't care what direction. So the distance traveled is 4, but what's the change in position? -4, because final minus initial. Right? See that? Last one. Drake, you still working? It was rainy all weekend.
yeah. I had to work out Saturday, but yeah.
I was like, they don't leave
Is it gonna be nicer today? Is it still wet out there? Can't imagine slogging around for like 3
Why
hours.
was we on
Four.
she was
Oh, that's not too bad.
I was worried about her, she was having a great time.
All right, you guys ready?
I said,
Doodling.
Mama was like, it was all professional people here. I need my own self,
Art.
my heels. They said they confiscated her wig.
If there's an
Art.
interlude,
Oh.
if there's
I
an
wasn't on
interlude,
it.
that is
Well,
not,
I
that
wasn't
is
on
not a
it.
moment to break into your phone.
Yeah, you're.
They let
Okay.
her take that for a break.
That is not a moment to bust into your phone if there is an interlude.
She was good.
All right,
I'm scared of her. She tried to yell at me this morning.
let's do the first one. From 0 to 2 seconds. Okay? From 0 to 2 seconds, what's the distance traveled?
Oh, yeah.
Yeah, it goes 2 meters. Because look, you started at 2 and you went to 4. Is that a change of 2? Okay? But what about the change in the position? Is that also 2 meters? It is. This is actually going to be really important for us to understand. Your dude started at 2, he ended at 4 after 2 seconds. He moved 2 and he moved 2 to the right. Okay? But what about the next 2 seconds? What about from 2 to 4 seconds? What was the distance traveled? At 2 seconds, what's his position? It's 4. At 4 seconds, what's his position? It's 0. He went from 4 to 0. If you went from 4 to 0, how far did you travel? 4 meters. It could not be easier. If you were at 4 and you went to 0, how far did you travel? 4 meters. But what do you think the change in position is? Okay? It's not the whole thing. I'm just talking about the time from 2 to 4 seconds. If you just look at the time from 2 to 4 seconds, what's his final position? 0. What's his initial position? 4. What's the change? 0 minus 4 is negative 4. Why is the distance different than the change in position for this interval? Check with your neighbor on this one. Why is the distance different than the change in position for this interval? Check your neighbor. Quick! Check your neighbor.
Different from what the first one?
These two.
Okay.
Why is your distance different than your change in position? That's all right. You're allowed to be confused. We'll get there. Why does your shirt say 1990?
That's the year I was born.
You're a liar.
Catherine.
Super senior.
Like, I don't
I
think.
just like the school. What can I say?
Why do you think the distance is different than the change in position? This is a hard question.
Because 4 is at 0.
Well, why do you think these two things are different at all? Okay? So Zaria is 100% correct. She said, if you notice this, now, this graph here, it shows the position increasing and decreasing. But remember, if your object is going to the right, it's moving up on this axis, and if your object is moving down, it goes, or if your object is moving left, it goes down on this axis. So what does this tell you about your object? What direction is it moving here?
It went to the right and then it went.
And this is,
Left.
that means that the velocity is positive because it's moving right, and the velocity is negative because it's moving left. These are different because this one here shows the direction. Okay? The change in the position tells you what direction your object moved. If it's negative, your object moved left. If it's positive, your object moved to the right. So, last question. What is the distance traveled total, and what is the total change in position? Okay? What's the total distance traveled? Roy says it's 6. Could it be 6?
From 0 to 0.
Could you have traveled 6?
Yep.
Well, look at it. He started at 2, he went 2 to the right and 4 to the left. If you went 2 to the right and 4 to the left, what's the total distance traveled? 6. And then, but the change in position doesn't care how far you moved in the meantime. It only cares about your original and final. So the final position is 0, the initial position is 2, 0 minus 2 is,
Wait, can you show you got 6?
yeah. Where's your object start?
2.
And then he went to the right, how many meters?
2.
And then went to the left, how many?
2.
Oh, okay.
Because remember, we're looking at the points as time goes on. Is that cool?
I thought we
That's
were
all right.
going straight from 2 to 0.
Well, we didn't go this way, right? He had to go away first and walk. It would work like this. So what I'm gonna do is I'm gonna start at 2, I'm gonna walk this way, then walk back this way. If I take 2 steps this way and turn around and take 1, 2, 3, 4 steps this way, how many total steps did I take?
6.
6 steps, but I ended up 2 to the left of where I started. So my walking would model this graph right here. Okay. I can't believe that took this long. I'm so sorry. You guys want to see something cool? You guys want to see something cool?
Yeah.
I'm sorry, Maureen.
I woke up late and I was like, what am I doing? You were just actually my bad. My mom was watching. Bro, I was so mad
Give me a
when I
bun.
heard her voice last night. I was like,
Jaden, give me that
bro,
bun.
why you got- They could have kept you another night, didn't they?
I was out last night. I was tired.
Bro,
All right.
I was really finna get into some stuff.
What do we know about this buggy? How does it move?
Constant.
Say forward. It moves forward. Yes, it does. Okay? The buggy 100% moves forward. We're going to analyze the motion of the buggy. All you got to do is watch. We're going to analyze the motion of the buggy. It's actually very cool. Wait till you see what happens. I'm going to use, to analyze the motion of the buggy, I'm going to use this device. You guys see this device right here? What does that say?
Motion detector.
So this is a motion detector, and what it does, it's actually very cool. Get this. It sends out a sound wave that's too high pitched for us to hear. You can hear it clicking, that's the on and off, but you can't actually hear the sound wave. The sound wave goes and hits the back of the buggy and comes back here, and the computer calculates exactly where the buggy is based on that. So although it says motion detector, it's actually what we call a positionometer. It tells you the position of the buggy. And give me that paper sticker. So here's what we're going to do. Okay, wait till you see this. This is so cool. Okay, I'm going to put the buggy 1 meter away. You see that? Oh, you can't see it. It's at the top of the board. It says collect. I'm going to press collect and watch what happens. Nothing happens. Then I jumped and I fell.
Broke a leg. What always happens?
Oh, look at it.
Okay. Tell me what you notice.
That one.
There's 2 things you're noticing here.
Straight line.
Well, they're both straight. Be specific. What else are you noticing?
The velocity is 0.
Yes, that is an excellent observation. What do you notice about the velocity graph? What is the value? 0. Does that go with the car?
Yeah.
How do you know the velocity is 0?
Because it's
Not
not
moving.
Because it's not moving. I know. What else do you notice?
the position is at 1 meter.
Yes, thank you. The position is at 1 meter.
1.02.
Okay? That's fine. What if I move it up here? And now I graph. What's going to happen?
1.2 meters.
Okay, let's see what happens. Oh, that was me. I was in the way when I started collecting. What do you notice? Is the velocity still 0?
Nope.
Well, I was
Oh,
in the way.
yeah.
The velocity is still 0, and where's the car now?
Like
About 1.3 meters?
Yeah.
Because I moved it away, true? here's what's gonna happen. I'm now gonna bring the car, I'm gonna put it here, I'm gonna press collect, I'm gonna turn the car on. What do you think the computer's gonna graph? You're not
Velocity.
testing the car.
Okay.
You should move the mouse so you're not moving.
I think I can do it. Are you ready? Set. Okay? I have the mouse. All right, so tell me what you're noticing. Okay? Give me one noticing. Hit me.
Goes up
Oh,
and then evens out.
So, what's happening to the position of the buggy?
It's moving.
The position of the buggy is